So balancing chemical equations has to do with things that we've already learned. So we've already learned some of these things. You don't even know it yet. All right, no. We're not even to the notes yet. First, I want to know, what is the law of conservation of mass state? Vaughn.
Matter cannot be created nor destroyed.
Perfect. Matter cannot be created or destroyed. More specifically, matter is not created or destroyed. It is conserved in a chemical or physical process. Okay? So that means that if I have 10 grams of my reactants, how many grams of my products or how much mass in the end should I have? Hopefully 10 grams, right? Oh, I got this for you. All right, my next question. What does Dalton's atomic theory say what happens with elements or atoms of elements? Dalton's atomic theory, what is it? Does anyone remember what it says about what happens with atoms of elements? You said something. Okay, there's one part. They can combine. That's one. Anyone else got anything to add to it? Gavin? Atoms of the same element are identical. Okay, good. What else? Carson? Yeah, they create a compound, so they combine in whole numbers to create compounds or chemical formulas. And then one last one. Can they turn into other elements? No. Okay, so they cannot turn into other elements. So Dalton's atomic theory, what it says that happens with atoms is they can combine in whole number ratios and they never can become other elements. All right, so now we're actually going to get into the notes. All right, atoms are not created or destroyed in a chemical reaction. So they're not created and they're not destroyed. Scientists know that there's going to be the same number of atoms on each side of the reaction or the equation. Okay, so each side of the reaction or the equation. In order to balance a chemical reaction, you must add what is known as a coefficient in front of the chemical formulas in the equation. And then you cannot add or change any subscripts. Okay, so I'm going to show you guys what a coefficient is here in a second and what a subscript is here in a second. We'll draw some arrows to that. But to start, we're actually going to look at an example that also goes over the rules of how we go through balancing. So there's kind of 4 steps that we use when we go through balancing a chemical equation. First thing that you do is you look at your skeleton equation. That's what this is called when there's no numbers in front. It's called a skeleton equation. So it's just the bones, okay? And you figure out what elements you're working with and you list those. So what I typically do is I draw a line down where my arrow's at to separate my sides, okay? So yesterday I asked you guys what's a reactant, what's a product. Reactants are on the left of the arrow. Products are what you make. They're on the right of the arrow, okay? Subscripts, that's going to be a subscript, that 2. Think of submarine, it's going to be below, okay? So it's going to be the number below. And coefficient is going to be the number in front, so it's going to be what goes into those boxes, okay? So that's what a coefficient is. So subscripts, submarine below, coefficient is the big numbers in front. So first we determine our elements and we determine the number of atoms of each element we have to begin. So if I'm looking at magnesium, Mg, I have no subscripts here, so that means I have 1 Mg. If I look at O2, how many O2s or oxygens do I have? 2. Okay. Looking at my product side, how many Mgs do I have? 1. What about oxygen? Also 1. Okay. So that's step 1. Determine the number of atoms for each element. Step 2. Pick an element that is not equal on both sides of the equation. So right now, Mg is both 1. So that means O is our one we're going to look at. Add a coefficient in front of the formula with that element and adjust your counts. When you add a coefficient in front, You're multiplying it by however many you have in that particular compound, okay? So we've got 2 oxygen here, we have 1 here. We only can multiply by whole numbers. So this is whole numbers only. Okay, so whole numbers only. So if I want this to be 2, what do I need to multiply the oxygen by on this side of the equation? 2. I cannot just throw a 2 in the middle of this thing. I have to multiply the entity, so the entire thing. So I'm going to put a 2 in this box. I'm going to do it in pencil. When I put a 2 in this box, what happens to my magnesium? Now there's 2. What happens to my oxygen? Now there's 2. All right, oxygen is balanced now. I've got 2 and 2. What about magnesium? Is it balanced? No, I have 1 and 2. Can I make this side become 2? Yeah, what can I do? Multiply magnesium by 2. So I'm just going to put a 2 here. I don't have to do anything with oxygen because it's set. When I do that, I now have 2 magnesium. Okay. If a box is empty or a spot is empty, it's assumed that's 1. We never write in a 1 usually with chemical equations because it's like math, right? You don't ever put 1x, you just put x. So just like in math, we just leave it if it's 1, okay? So if we were to actually write the balanced equation of this compound, it would be, or of this formula, it'd be 2Mg plus O2 becomes 2 magnesium oxides. That is the balanced chemical equation. All right. So here's what I'm going to have you guys do. I'm going to give you 3 minutes, I think, 3 or 4 minutes, and I want you guys to attempt Ca plus O2 becomes CaO, and N2H2 and NH3. I want you to try just these 2 with your table mates, okay? Just this one and this one. If you think you've got it, you have the freedom to work on to the next 2, but don't do anything beyond those 2, okay? So just the first 2, and then we're going to check them. All right, so I've got CaO2 and CaO. So on my left side of my arrow, I like to draw my line so I can visually see where the difference is at. So calcium, I've got 1 on the left side. I've got 1 on the right side. Oxygen, I have 2 on the left. How many do I have on the right? 1. Okay. All right, so that is step 1. Step 2, pick an element that is not equal. Is calcium equal? Right now. Is oxygen equal right now? 2 and 1, that's not equal, okay? So we need to pick a coefficient that's a whole number that we can use to multiply by to make them equal. So this one's going to be 2. So we're going to put a 2 in this box. When I do that, I now have 2 calcium and 2 oxygen. All right, oxygen is balanced. Do we see? Is calcium balanced? No. Okay. What can I do to this calcium to make it balanced with this one? Multiply it by 2. When I multiply that by 2, I now have 2 calcium. I'm going to double check that everything's balanced. 2 calcium, 2 calcium. That's good. Oxygen, 2 here, 2 there. We now have a balanced equation. Does that make sense? Okay. Yes, Brett.
Why is the oxygen, why is the oxide have no 2 in it?
Because you only multiplied the Ca. If you would have multiplied this by 2, this would now be 4, and you have to change everything. Does that make sense?
Yeah.
Okay, let's look at our next one, okay? So our next one, drawing our line. All right, on my left side, how many nitrogen do I have? 2. How many hydrogen? 2. Okay. Right side, how many nitrogen? 1. How many hydrogen? 3. Okay. All right, here's a rule of thumb. When you have an odd and an even, take the odd and multiply it by 2 because it's going to make it an even. Does that make sense?
Yep.
So I've got two things unbalanced. I've got 2 and 1, 2 and 3. The only way to get these balanced is to make them even. And the easiest way to do that is to start by multiplying by 2. So we're going to put a 2 in front of this side. When I do that, how many nitrogens do I now have? 2. Okay. How many hydrogens? 2 times 3 gives us 6. Okay. All right. Nitrogen is set. Nitrogen's balanced, 2 and 2. Is hydrogen balanced? No, I've got 6 and I've got 2. I've got H2 up here. What can I multiply H2 by to make it 6? 3. So I'm going to put a 3 in this box. When I multiply 3 times 2, I get 6. This one is now balanced. How do we feel? Feeling a little bit better about this? Okay, I want you guys to just try this one. Okay, just try this one next. So I'm going to give you guys a roughly 3 minutes. Go ahead and give this one a try. If your group already did, hang tight or attempt the challenge one, which is at the bottom. Okay, so we're going to draw our line down from the arrow. And we're going to do our counts. So how many copper, Cu, is on the left side? 2. How many oxygens? 1. And how many carbons? Okay. On the right side, how many coppers? 1. How many oxygens? 2. And how many carbons? Okay. A little rule of thumb. Notice that the order of the elements changed on the right side, but they kept the order of the elements the same. When you're doing these, you're going to want to do that. Otherwise, you're going to throw yourself off. Okay. So you want to make sure that you write them in the same line in a sense. Okay. I've got 2 copper on the left. I have 1 on the right. What do I need to do on the right? Multiply by 2. Okay. So we'll multiply by 2 to start. So now I have 2 copper. So right now, copper's looking okay. All right. What about oxygen? I have 2 on the right. I have 1 on the left. Multiply this by 2. Okay. Okay. So what happens here, though, with copper? I have 2 times 2, so that changes to 4. And I have 2 oxygen. So right now, oxygen's okay, but copper is not okay anymore, right? Copper now is at 4 and 2. Can I change this? What should I change it to? 4. So if you change that to 4, we have 4 copper, 2 oxygen, 1 carbon. Are we balanced? Yeah, we're balanced. We're good to go. Okay? So a little rule of thumb. When you're working on these, there are going to be a lot of times where you have to change your coefficient a couple times. So either work in pencil, or when you're working with some of these, like in class practice, you guys can use the whiteboard so it's easier to write. Okay? We are going to do this one. We're going to talk through this one together. So we're going to work through this one together. Okay? So drawing our line. All right. Side conversations ending in 3, 2, 1. Thank you. All right. How many hydrogen do I have on the left side? 2. How many oxygen? 2. Okay. How many hydrogen on the right side? 2. Okay, this is where things get weird. I have 2 oxygen here. I have 1 oxygen there. You add them. 2 plus 1 equals 3. Okay. When you have an odd number, you want to make it even. So make the odd even. And in order to do that, you usually multiply it by 2. So my right side is odd. I need to find where it's odd. It's not odd here, but it's odd in H2O because there's only 1. So I'm going to throw a 2 in this box. When I throw a 2 in that box, I now have how many hydrogen? 4. I now have 2 oxygen here plus this 2. So 2 plus 2 equals 4 oxygen. All right, let's look at my other side. 2 and 2, 4 and 4. What do I need to multiply this by? 2. When I multiply it by 2, I get 4 and 4. Are we balanced? Yes. Okay, if you flip your sheet over, these are independent practice problems. You do not necessarily need to start them today. I'm actually officially assigning them to you tomorrow. They are going to be due Monday. Tomorrow in class, we're going to be doing a bunch of like in-class practice where I give you the slideshow, we do practice, and then we go over the answer. But these will be due Monday. So if you want to start them, you're more than welcome to, but just so you know that. For the rest of class, you guys have your part 1 and your part 2 of yesterday's assignment, the balancing chemical equations inquiry set to finish. Part 1 is going to be due by midnight tonight. Part 2 is going to be due in the basket tomorrow.